All right, good morning here again. We have our Thursday lesson. This is, I think, number 15. And we are doing a lesson really quick on what we call plate tectonics. Nice picture of Mr. Jensen down there, excited to share the plate tectonics. If you've done lesson 12, 13, and 14 before this, then you've built up to this last short, quick lesson. All the ideas come together in this one. And that is, we talked about how we analyze and interpret data on the distribution of fossils. That is when we talked about continental drift, Alfred Wagner, the fossils that are all over the world matching up continents together, as well as the rock forms. Some of the mountain ranges match up together. South America, Africa seem to match up together with fossils and mountain ranges and things like that. Also, their continental shapes fit together like a puzzle piece. And then we talked yesterday about seafloor structures. We saw that the seafloor is actually spreading apart. And we looked at evidence of that. We looked at new molten rock that was created right there at the edge of the seafloor spreading, those big pillow basalts. We talked about the magnetism, how it's changed in bands that are equal right there with the opening of the seafloor spreading. And then lastly, we also talked about how they took and dated the rocks, starting at the actual split crack all the way out. And they found that it got older as you went further away from where that seafloor mid-ocean ridge was. So lots of evidence that we put together to come up with this idea that these continents are drifting. And now the plate motions. We came up with a theory that scientists like to call plate tectonics. You ever dropped a hard-boiled egg? Hopefully not, but I have. If so, you may have noticed that the eggshell cracked in an irregular pattern of pieces, meaning just randomly. The Earth's crust is highlighted there. Its solid outer shell is not one unbroken layer. It's more like that cracked eggshell. It's broken into pieces, separated by jagged cracks. And you can see on this that there are all these little cracks going in different directions. And these eggshell pieces that we have kind of resemble the pieces on our Earth that we call plates, Earth's plates. Canadian scientist J. Tuzo Wilson observed that there are cracks in the continents similar to those on the ocean floor. In 1965, Wilson proposed a new way of looking at these cracks. And according to Wilson, the Earth's crust is broken into separate sections called plates. The plates fit together along cracks in the Earth's crust, as shown right here in this picture. The plates carry the continents or parts of the ocean floor, or maybe even both. You can see there's cracks going right through the ocean right here, right down the middle of the ocean right here. I know the color scheme kind of looks weird, but you can kind of see a darker color behind this pink. The darker color is the continents. The lighter color is the oceans. Same thing with this orange. The darker orange is Africa. The lighter orange is the Atlantic Ocean. The crack goes right in between it, just like it kind of does on land. Wilson combined what geologists knew about seafloor spreading, that's Earth's plates, and continental drift into a single theory. So he took seafloor spreading, he took continental drift from Wagner, Harry Hess's seafloor spreading, and Wilson took all these cracks and everything and put it together into one big idea called plate tectonics. The theory of plate tectonics states that pieces of Earth's crust are in slow, constant motion, driven by the convection currents in the mantle. Remember, the convection currents are where that hot molten rock is coming up from the center core of the Earth, and it's moving those plates as it comes up and through and then sinks back down at subduction zones. There's Mrs. Adkins right there, killing it. Get it? So the theory of plate tectonics explains the formation, movement, and subduction of Earth's plates? Heck yeah, that's what it is. It's explaining how these Earth's plates are moving. And you can see in this diagram blown up for you, there are red arrows that are pointing in the direction that the plate is moving. So if you look at this blue Pacific plate in the middle, all the arrows on the blue plate are all moved pretty much in the same direction. That's how that plate is moving, like this, all the way through. And then you can see on the other side, the green plate is showing that it's moving in a different direction. So they have arrows showing the way that the plates are moving, and they've colored these plates to make the different plate colors. But how can Earth's plates move? Mr. Wagner's still confused. What force is great enough to move these heavy continents? And all the class in Magic School Bus is going, yeah, Wagner, what is it? We can barely hold this thing together. How in the world is this going? They piece it together. Geologists think that movement of convection currents in the mantle is the major force that causes the plate motion. But Mr. Jensen, we've never actually seen convection happen in the mantle. We've only seen some of the evidences from volcanoes. We've only seen some of the evidences from seafloor spreading, but we've never actually seen this. You're right. We've created this movie. This is not a real movie of what it looks like. This is one that we've created on a computer, but we're thinking because of what we can observe on the outside of the Earth, this is probably what's going on the inside of the Earth. This is what we're thinking. Second paragraph or second sentence says, during subduction, gravity pulls the edge of a plate down into the mantle. Or excuse me, edge of a plate down into the mantle. The rest of the plate also moves. As the plates move, they collide. They pull apart or they grind past each other, producing spectacular changes in the Earth's surface. These changes include volcanoes, mountain ranges, deep ocean trenches, like Challenger Deep, the Marianas Trench, deepest place in the world that we know about. All these things happen because of plate tectonics. It's the theory explaining how we got deep trenches in the ocean. How did we get Mount Everest in the Himalayas? How did we get big open valleys? How did we get these mountain ranges under the ocean? All this stuff is explained by using the theory of plate tectonics. What is the theory of plate tectonics? Well, what I want you to do is open up the other document, Google Slides, and go to the same, it's the same slideshow that you're seeing me show you in this video. And at the very last slide, there's a box at the bottom. You'll just click right in the box. And I want you to write down what is the theory of plate tectonics, just to see what you think. If you can't get to that, not a big deal. But give it a shot. Try it out. Thanks so much for watching. Hope you enjoyed this last part of the week. Have a great weekend.